The James Webb Space Telescope has discovered something that seems impossible: a faint glow of city lights 7 trillion miles away from Earth. The discovery has captivated cosmologists around the world and has forced us to rethink our understanding of the universe. Could this distant glow signal the presence of an alien civilization? And if so, what does it mean for humanity? Since its launch on Christmas Day 2021, the James Webb Space Telescope, JWST, has surpassed its predecessor, the Hubble Space Telescope, in capturing unprecedentedly detailed images of distant galaxies and newly discovered planetary systems. The mission is to study the origins of the universe's first galaxies by observing the light that has traveled billions of years to reach us. In 2022, JWST released its first deep sky image showing a universe filled with galaxies that are more than 13 billion years old. One of JWST's deep image targets is the galaxy cluster SMACS 0723, 4.6 billion light-years away. Its massive gravitational field acts like a cosmic magnifying glass, bending the light from more distant galaxies behind it and stretching their shape into a giant arc. These observations not only allow scientists to peer deeper into the universe's past, but also help reveal how galaxies merged to form structures over eons of time. Unlike previous telescopes that took days to collect similar data, JWST took just a few hours to capture these stunning views. JWST's capabilities extend beyond static images. By studying the changes in light passing through the middle clusters of stars in certain galaxies, such as VV 1911, scientists can also analyze the dust properties of the galaxies between them. This has led to unexpected discoveries, such as auroras on distant brown dwarfs, a feat that JWST accomplished without a host star. Like the auroras on Jupiter and Saturn, these emissions are a result of charged particles interacting with magnetic fields. But the brown dwarf WISE J 1935-1943 has no nearby star, leaving scientists scratching their heads as to the source of its energy emissions. Intrigued by the possibility of extraterrestrial life, JWST has also turned its attention to Proxima Centauri and TRAPPIST-1, both of which are located within the Milky Way and just 4.4 light-years from Earth. Discovered by NASA's Spitzer Space Telescope, the TRAPPIST-1 system boasts 7 rocky exoplanets, at least some of which may have water on their surfaces. JWST recently calculated a temperature estimate for TRAPPIST-1b, a feat no other telescope has achieved for such a small and distant planet. The telescope also discovered a reddish-brown supermassive black hole, which is devouring everything in its path, with a mass of about 40 million times that of the Sun located a whopping 129 billion light-years away. This ancient black hole has existed since the dawn of time, slowly devouring its surroundings. Its crimson hue suggests that it is covered in dust, giving scientists clues into the mysteries of the black hole surroundings and galaxy evolution. In addition to studying the black hole and distant galaxies, JWST has also captured unusual light patterns, including a mysterious question mark shape. This oddity, thought to be the result of interactions between galaxies or clusters, hints at yet-to-be-explained cosmic phenomena. JWST's ongoing observations of the TRAPPIST-1 system have fascinated astronomers with the possibility of finding habitable worlds. These Earth-sized planets orbit M-class red dwarfs, which are cooler and smaller than our Sun. While the closer an M-class dwarf is to a rocky planet, these stars often emit flares that can potentially damage their atmospheres. But studying TRAPPIST-1b has yielded new insights. JWST's temperature measurements indicate that it lacks an atmosphere, suggesting that it may be a rocky, if not habitable, world. On the other side of the universe, JWST has become a meteorologist, documenting the unstable weather conditions of a distant gas giant known as WASP-43b. Orbiting its star in just 19.5 hours, the exoplanet is exposed to extreme conditions, with daytime temperatures reaching 2,200 degrees Fahrenheit, hot enough to melt metal. While this side of the planet is constantly bathed in starlight, the night side remains in shadow, with high-speed winds transporting heat between the two. The unprecedented scope of the James Webb Space Telescope has opened up new realms of discovery, revealing complex layers of galaxies, star systems, and planets. Each observation brings us closer to solving the mystery of our place in the universe and the possibility that we may not be alone. The latest discoveries from the James Webb Space Telescope are pushing the boundaries of our knowledge in ways we never imagined. As the telescope continues to peer deep into space, it is also uncovering clues about how life might exist elsewhere in the universe. One of the most important implications of these observations is the potential to detect biosignatures, signs of life, in the atmospheres of distant exoplanets. Using a technique called spectroscopy, JWST can analyze the light passing through an exoplanet's atmosphere to look for chemical signatures associated with life, such as oxygen, methane, and carbon dioxide. The delicate balance of these gases can signal biological activity, which could indicate an active ecosystem. This search for biosignatures has heightened interest in the rocky planets of the TRAPPIST-1 system, where some planets orbit within their stars' habitable zones, the area where liquid water can exist. JWST spectroscopic data from TRAPPIST-1e and TRAPPIST-1f could reveal whether these worlds have atmospheres that could support life. The possibility of finding microbial life on other worlds, while unlikely, would be a revolutionary discovery, one that would change the way we see ourselves in the universe. But because telescopes look outward, they help us look inward and tell us more about the building blocks of life on Earth. By studying distant star-forming regions, JWST identifies the chemical components involved in the formation of planets and stars. These discoveries allow scientists to trace the origins of organic molecules, such as carbon and water, essential to life. Understanding where these molecules came from and how they are distributed throughout the universe can help answer questions about how life began here and whether it could have begun elsewhere. The telescope's observations have also sparked renewed interest in objects closer to us, such as the icy moons of Jupiter and Saturn, where scientists think life could be hidden beneath thick ice shells. Europa, one of Jupiter's moons, has a vast ocean beneath its icy surface, and Enceladus, a moon of Saturn, emits plumes of water vapor from its south pole. JWST's infrared capabilities could help analyze the composition of these moons' plumes and ice, providing hints about the organic molecules and chemical reactions that could support life beneath their surfaces. Meanwhile, JWST's studies of black holes, star formation, and cosmic dust show how the universe's large-scale structure evolved. By observing some of the earliest galaxies, astronomers are piecing together a story of how stars and planets formed and organized into clusters, galaxies, and superclusters. The gravity of these structures shapes the universe, creating cosmic highways that lead to distant galaxies. As the telescope continues its mission, new questions are being asked. Could there be other planets in our galaxy or beyond that are home to advanced civilizations? Will humanity ever explore distant worlds beyond our solar system? For now, JWST remains a window into the unknown, capturing images and data that could forever change our understanding of the universe. Every image, every new data point brings us closer to answering some of humanity's oldest questions. Are we alone? How did it all begin? And what else awaits discovery? With its groundbreaking technology and infinite reach, the James Webb Space Telescope reminds us that our place in the universe is small, but our curiosity and wonder are infinite. He peers into the darkness, brings us closer to the universe, ignites our imagination, and challenges us to dream bigger than ever before.